I'd like to welcome everybody to part 7 of the ESTeem training class. And for this day, what we're going to do is we're going to cover some of the advanced features in the advanced configuration menu within the ESTeem products, primarily concentrating on the Horizon series. Where we've gone so far in this training series, we've covered the basics of radio communication, from antennas to cables to radio propagation. We've gone into how the ESTeem products fit within this greater radio world. We've gone over the primary means of communication, the bridging, the routing, everything that has to do with wireless Ethernet side. And now we're going to take a look at some of the details of what need to be set within the radio to get it to function in just about any type of application. The first thing that we're going to take a look at is we're going to cover again the front panel, because there are actually 4 different ports on the front of the radio. We've actually got 2 Ethernet ports, the primary and the secondary ports. The primary port being here on the far right hand side, the secondary port being the one on the left. What we're going to be, everything that we've talked about primarily goes through one of these 2 ports as far as the bridging, routing, firewall type of communications. The RS-232 data port has special use characteristics primarily for legacy hardware, those type of controllers that do not have a communication interface at an Ethernet port yet. This allows the Horizon series to be put into a wireless communication network, and we can support both the legacy RS-232 data and Ethernet at the same time. The first thing we'll concentrate really though on is this RS-232 configuration port. Now this configuration port is a little bit unique in the fact that it's really designed as a fallback port if all other ports are not communicating. You do most of your communication programming through the radio into the web interface in the radio, so you're going through the Ethernet interface. There really are very few conditions that the radio can be put into to where you cannot get type of response out of the radio. The one that, if it were to come up more often than any other, is if the radio is configured as a DHCP client, where it's looking for a server to give it an IP address, and there is no DHCP server on the network, then the radio will go out and listen and try to get that communication. But up to that point, it has no IP address, so it cannot respond. In a condition like this, the only way to really get back into the radio is to go through what we call the RS-232 programming port. It is always a fallback port because it does not allow you to do all the features that you can do within inside of a normal interface port, but it will get you back to a working state. It is actually at a fixed data rate, so it will always be at 115,200, no parity, 8 data bits, 1 stop bit. You're going to go into the RJ45 connector, which is listed as RS-232 programming, which we saw in the previous slide. And any terminal program, it doesn't matter if you've got an older hyperterminal, TerraTerm. A lot of serial communication is done through PuTTY now because it's an open source engine. What this does, though, it uses the same username and password that is set into the web interface. So if it is changed, you'll need to enter it there. It allows you to do really a shorter subset of the communication available into the radio. It allows you to do the critical information, let's say, to where you need to change the IP address, or we need to look at the log file, or we need to, we can actually go in and ping directly from the radio itself to verify that the communication is there. Through each one of these, just will give us the ability to actually give the radio back an IP into a known state. I'm going to bring up on the screen what portions of this are actually available when we go in through this RS-232 port. Now I'm actually going to be going through what's called the Telnet interface, which it's going to give you the same responses that the serial does, except Telnet really is the port that allow you to do the same information. The only difference being that telnet port goes through the Ethernet, but the login is everything the same. So I'm going to log into it just like I did through the web browser. So the username is going to be admin, ADMIN, and then the password is also admin, ADMIN, all lowercase. But as you can see here, we do not have the ability within the serial or the telnet interface to do all the features that we could do during the web interface. We can't really change the mode of operation. But what it does allow us to do, it allows us to get to that critical point. We can set it to factory defaults. We can configure the Ethernet port and reboot the radio. We can configure the Ethernet interface. It will allow us to put it back into a working state. But as you can see, we really don't have all the features that are available to us generally on the other modes of operation. That is really the only downfall to it. But it will give you the opportunity to put it back into a good working state. Outside of the RS-232 port, there are a couple unique configuration questions that come up during the setup tab. And one of those is what's called a maximum distance. And this really is based upon the fact that these radios, because they can be used with very high gain directional antennas, up to 21, in some cases even to 23 dBi, we can create RF links that are multiple miles long. Well, what the radio needs to know is we need to know what this maximum distance is from any one radio to any the furthest distance that it's going to link to in the peer configuration. The reason we need to do this is we need to give the radio enough time to send the communication out to the remote and expect a response. Well, one thing that's changed of the radios over time is we've really scaled the factor of communications. These newer high-speed radios, they really can look at times into the microseconds. Well, now that we're dealing with microseconds instead of milliseconds as far as timing, we're getting to the point that the radio really has to wait on the communication or the electromagnetic communication to go between 2 points that's traveling at the speed of light. So there is a certain amount of delay that it takes for it to reach the remote and come back. Well, what our max distance does is it allows the radio to not wait indefinitely, but it'll wait enough time to where if you have it set to a low value and you have a link that is 10 miles, then what would happen in the communication side is the radio would transmit out, not receive the acknowledgement that it expects. It will automatically retransmit information once again, and at that same time it will receive the response from the first packet. So it would not disable the communications, but we're making the communication very inefficient. And that was actually showed up with inside of the programming. And let me go ahead and I'll bring it up here on the screen so we can see what I'm making reference to here. When we were going through the configuration of the radio through the web interface, we went through and started with this setup tab. Now, inside of the setup tab, if the radio has already been programmed one time, what it will do is as soon as you hit setup and hit next, it's going to bring up really what this is this is a sub menu for all the different categories that are for the configuration of the radio. For example, if we did not want to change anything that has to do with the IP, the root bridge, the DHCP server, anything like that, the only thing we were concerned with is we actually wanted to change, say, the distance. Then you can move the radio down to the distance tab, press next, and what it will do is it will jump through the configuration until you're on the page that covers specifically the distances and the bandwidths. The nice part is that once you were to make a change, let's say we had a link within our network to be 7.5 miles. Well, what we want to do is always want to round up to the next highest single digit. So that would be 8 miles. So as soon as we set that, we could actually hit next. And then from the menuing system, if we didn't need to change any channels, didn't need to change any frequencies, that was the only thing that we needed to change, we can actually hit this button over here that says skip to the commit page, and it's going to jump us all the way to the end. So we don't need to make a modification to each one of the pages in between there. It is one of the quick ways to get back and forth between the individual pages. So now that we've covered the components of the radio, as far as the RS-232 programming port and the how to get into it through the serial port and what that would look like, there are a few things that can be adjusted within the advanced menu. The first cautionary statement that I'll put out there, though, is you really only want to change the items in the advanced menu that are either instructed to you by support or that say to within the user's manual. Where this really comes from, it is an invalid input can disable the communications, because what you have access to is all of the timing parameters within the radio and how it operates with other ones. So if you start adjusting those parameters, it is a decent possibility that you could put in something to where the two radios just will not see each other. Not that it's going to, damage the radio to a point that it comes back. You can always set it to factory default and reprogram it. But because you have access to all these variables, you really only want to change the items within the advanced menu that you know where they're operating to, and also that are required to do so. The three primary changes that we'll do, and we'll take a look at all the available items within this menu, but the ones that we really are going to need to be concerned with is how to change the modem ID, because you can set that on that last page that we saw here on the configuration page, so I'll come back to that. It will actually allow you to change what we call the diversity antenna. For example, if you have two receive antennas on the radio, what it will do is it actually has the ability to sample both of those antennas and will pick the best signal between the two. That is very beneficial if the radio is indoors. It's going to be an area that you're picking up a lot of reflected signals. Say, for example, around a oil plant, something like this. It's got a tremendous amount of metal structure around it. What it will do is it actually looks at the reflected signals coming from both antennas, and it picks the best of the two. We have the ability to adjust how those operate. Because really what it comes down to is if you have a single antenna, there's no reason to run antenna diversity on the second antenna. So we'll actually show you how to adjust that. And the other thing that may need to be adjusted is actually the output power in the radio. The output power in the radio is always shipped at maximum power, but if you're in a very low distance application, putting it at max power, you may be causing your own interference. So you may need to adjust the power level to get your signal strength down to a point that it is within acceptable values between the radio. So let's go ahead and take a look at a couple slides, what I'm making reference here to. When we're talking about antenna selection, really depends upon the number of antenna ports that we have available. The radio that I'm currently plugged into is actually one of our Horizon 900 megahertz radios. That particular radio only has one single antenna port. Our 2.4, 4.9, and 5.8 actually have two antenna ports. Some of them will only transmit out of a single antenna port. So the 2.4 and the 4.9 only transmit out of one port, but will receive into two. The 5.8 gigahertz actually has a multiple in, multiple out transmitter, so it can transmit out of both ports and receive out of both ports. So to be able to get in and adjust it for the application, we would do that through the advanced configuration. So the numbers that show up here correlate to the individual port. So for example, if you had a value of the receive antenna port number 1, you'd set it to a value of 1. If you only wanted it to receive out of port number 2, you'd set it to 2. If you wanted to receive out of both antennas, you set it to a value of 0. 0 will actually select both of them. So let's go back to our web page in the radio and see how that's actually set. As I mentioned to you before, when we made the jump to the commit page, you can adjust the radio ID here within this page. We could put it at test or whatever you wanted to put in there just as an identifier. But I'll show you where you can see that also in the advanced configuration. So if we jump over here to the advanced tab, you'll see here in the red text the same cautionary information that I just gave you. Adjustments to the values may result to the radio does not work. So this is not something that you'll use as a primary means of communication, but there are a few fine tuning that may need to go on inside of here. For the most part, though, you generally will not need to get into the advanced unless support tells you to do so, or you find something about it in the user's manual that you may need to want to see. So as you can see here, there is a breakdown because there are so many different variables to it. We have everything from the global variables, remote access and services, IP and EB tables, setting the system time, everything that has to do with the radios, both on what we call the wireless LAN, which is the primary radio communication. We also have the ability to set up a secondary wireless link. We've actually got several different articles on how we can configure what we call a dual Y bridge, which you really set the radio for two wireless networks operating into the same time. It separates them actually by the ports on the front. So you could have a control system going into one port, and you could have either like a Wi-Fi interface to where people can access it, or a secondary port that does things like video. These are the things that are the capabilities for it. They're kind of outside of the scope of what we want to cover today, but we've got great write-ups on how each one of those is done. As a comparison to that, we also have the network settings, where you set everything from the parameters of the Ethernet 0. So what I'm making reference to now is when the radios are listed, the way that it shows up is this is the primary port. So this is actually going to be listed as ETH0. That is the primary port. The secondary port is going to be ETH1. Same thing as far as the communication ports, the way that it looks at them. So we're going to have the RS-232 data port here, and this is differentiated because this is the configuration port. So if we go back to the settings within the radio, you can see here we break this apart by Ethernet 0, Ethernet 1, and then depending upon how the radio is configured, we can create really multiple bridges. So we're bridging together the Ethernet port 0 to the 1 RF port, or we can bridge a secondary Ethernet. It's a very, very sophisticated device. We can do tremendous amount of different type of applications. So if you've got something that sounds a little bit different than something that we've covered in either these training classes or you're not seeing in the user's manual, please give us a call. We'll be happy to walk through you. There's very few configuration parameters that the radio cannot function in. You'd be surprised that the different types of settings that the radio can be set for. To getting back to the modem ID, that's actually set under the global variables. So if we set global variables, hit the button that says next, what this will do is this will open up all the global variables. Now, as you can see in here, there's a lot of different things that could be, if it were changed, something that's different wrong. Where does the IP devices go? What are the NAT devices? In other words, what is it looking for as far as a name server, the base time, the host name? These are all things that we don't want to change unless specifically told to do so. But if we want to take direct control and change the radio ID, it's listed under the global settings. So the other two things that we had talked about, we had the ability to change the antenna configuration. Well, the antenna configurations are listed under the wireless LAN settings. So what we do is we select WLAN 0 device and hit the button that says next. And again, what it'll do is it'll show us a submenu. Now the basic chain setup, the primary one we have here, that is the same setup chain we walk through when we do the setup tab here. So what we want to do is we actually want to get directly into the advanced settings. So what we do is we change the radio to advanced settings and hit setup. It will then open up the next window. And as you can see here, there are a tremendous amount of different parameters that could be set within the radio. So the ones that we're going to be concerned with really are, again, only the ones that you really need to change. So the things that you may need to change in the long run, say for example, are your transmit and your receive antennas. So this one's going to be a little bit different because I only have a single antenna. If you do the little drop down, I only actually have one antenna port available to me. But if I had the 2.4, the 4.9, or the 5.8 gigahertz radio, you'd hit the drop down, you'd have all the possibilities that the radio can do. So if it had a single antenna as far as the transmit side, like on the 2.4 and the 4.9, you'd have the ability to do 1. If it's on the 5.8, it would say 0, 1, and 2. So what the radio has the capabilities of, this allows you to fine tune it. And again, you don't necessarily need to change this for every application, but there are certain conditions that met. Again, if you're generally going to be requested to do this from support, will primarily tell you where to get to. It's just a good idea to know exactly where these are located. The next other thing that we were talking about is actually how to set the power level within the radio. Now, the power level in the 900 actually has 3 different settings. Some of the other radios actually have 4 different settings, depending upon how it breaks down. And the way it works is we have it listed by max, high, low, and on some of them we actually have minimum. And the way that this is set is the maximum value of the radio output power will be set under max. So, for example, the 900 has a maximum output power of 1 watt. So each division below that is 1/4 of the power. So we can set this for max power, which is 1 watt, high, which is 0.75 watts, low, which is 0.5 watts, or even on the other radios, we can set it to 0.25 if they had a 1 watt output power. So those are really the only parameters that we really need to be concerned with within the advanced configuration. But what I want to do is just kind of give you a tour of what other possible settings are in there in case you ever need to make modifications to it. So let me jump back here really quick. And what I can do is to get back to the previous menu, you just scroll down to the bottom and you can either hit accept if you want to accept the changes that you made on the page, or if you're not certain of what you want to save, you can just hit cancel. It'll take you back to the previous menu. So as soon as we hit cancel, you'll see here we've got the basic chain, we got the peer settings, which is just a short form of being able to get directly towards the peer setting page within the radio. As you'll notice that the advanced menu, there's not a lot in here that we haven't already programmed for. This just allows you to jump towards those parameters and set those directly to it. Say, for example, the access control list settings, which we covered really exclusively in the last 2 sessions. This allows you to jump directly to those settings. We also have the ability to look at the packet monitoring and the radio on, so we can measure the forward reflected power out of the radio. So if we needed to check that, we simply go into the advanced, go to WLAN 0 settings, hit radio on, we go into setup, and from here, what you can do is it will allow you to set up what bandwidth you want it to transmit on, for how long, what kind of duration, and then you can turn the radio on and it will transmit out and you can measure the forward reflected power. So a lot of the characteristics that we're going to cover when we get into the troubleshooting section of the radio and the advanced of it, this is where we're going to get in and take a look at much more greater detail. So everything that you see here is covered under WLAN 0. So if I hit cancel, we'll come back to the main menu. The only other things that are necessarily to be concerned about is if you're looking at some primary settings in the radio. For example, as we mentioned earlier, this is a full-blown Linux-based computer. So you can actually set up the IV tables and the EB tables as you would in a Linux computer. It allow you to do everything from fine-tuning on the routing or particular packets or routing to it. The radio can actually be set up for those. The setting of the system time, there really isn't a real-time clock in the radio, but there is a small little battery device inside of there. So once you set it, it will hold its time as long as it isn't set on a shelf for years, but it will hold its time for several months. So it's nice if you're coordinating that, because these time parameters that are set here, this is what actually gets put into the log file. If you needed to review it, at least it's going to give you a better time. You can actually link the radio to a time server. So that is one of the variables that we saw up here under global variables. So under the, say, the NAT device, okay? So those allow you to actually get in and link the radio to a time server. So there are many advanced features that are available to it here. A lot of them are really very niche for the type of system they're going into. So what we'll do is really only be concerned with the ones that we're going to use over and over again. So if we take a look really quick at like Ethernet 0, and we click next on it, what it does is allow you, it gives you the idea of what the MAC address is configured for the radio, the current IP address for it, both primary and secondary ENS, the gateway, everything that there has to do with Ethernet 0. You can set everything from the speed in here to the duplexing for full and half duplex. This actually gets overwritten when the radio is cloned. So these are the parameters that get set in here so the radio looks like it is either going to come out of the factory or is the settings for another device. Same thing if we look at, say, the WLAN 0 device. What it will do is allows you to get in and fine tune it to where you could adjust the MAC address on the wireless side. Most of these parameters are automatically done. The only reason I'm even bringing them up here so that if you do see what they are, what they actually then function as. One of the things that we had covered on the last section when we covered routing is putting in static routes. So to be able to put in a static route, you actually click down here to the static route table and hit next. And then you can create your static route table from this page. So there are a lot of parameters that can be set into this advanced menu. And again, this really is something that will generally only be used for very specific applications, and really you're only going to need to get inside of that if told to do so, either through the utility, through the manual, or when talking to support. So what are some of the other parameters that actually get set inside of here? Okay, the modem ID we've covered. That is actually shows up in a couple different locations. That is actually everything from the radio. It could be its location, it could be a street address. It's really what it does is it gives a more human element to, instead of giving it an IP address or a MAC address, this can put a little bit more human aspect to it. So when it shows up, when you go into the discovery, it'll show up and show you the modem ID. If you are inside of the wireless status page, which shows you the radios that it's linked to, it'll show you the location there. So you don't have to constantly look for a cross-reference to an IP address, a MAC address, something like this. So it is a very, very valuable tool. That's one of the reasons that we put this as one of the last things that you set before you set the configuration for it. The radio being a Linux-based radio, it can actually be set up to do what we call a remote syslog, which really what it does is it pushes all the log information into a syslog server. There are many open source, free to download syslog servers, or if you wanted to incorporate that into your larger system, you could do that also. Setting of the system time. Again, the radio itself has an operating real-time clock in there, but it's about as accurate as really as a computer clock. There's nothing that use to it, but you can link either all the radios together or to an outside time server if you need to synchronize them all together. From the wireless LAN side, we've got the dual diversity, which we talked about as far as the antenna settings, setting of the data rates, the output power, and there are some details that we can get in and set up for SWR measurement when we're talking about the radio on. We can enable the transmitter so that instead of just looking at small packets in a analog type test piece of equipment, you need to be able to hold that transmitter on for multiple seconds so that you can measure it going forward. That's where we can get in and adjust that. The bridge and route variables. We showed you where the static route tables are set, the bridging variables. The one thing that I will take a jump back here real quick is once we get into the bridge variables, there's two things that we're going to look at. First, we're going to take a look at where spanning tree is turned on and off. And the next thing is if you have multiple route bridges. So for example, everything that we covered in the configuration page when we were talking about making a mesh, and we talked about having a single route bridge. Well, if you had a redundant master radio at the master site, what you would do is that you could either configure them both as a route bridge, and then one of the two radios would become the route bridge. If you don't care which one, that's one way to do it. The next thing is that you can also specifically set which ones are set up as a route bridge. So let's jump back to the advanced configuration page so we can take a look at what that does. So if we come back over here, we now are showing here the advanced configuration page. Then what we'll do is go into BR0, which is our bridge device, select Next. And as you can see here on this page, currently all the ports, because the radio is an AP bridge, so we're actually bridging Ethernet 0, Ethernet 1, the two Ethernet pages, and the WLAN 0, which is our essentially the RF port. All of them are bridged together, so whatever comes in one is going to go out the other point. There are situations to where the radio gets put into a larger communication network, where we're hooking into a switched network or in a routed network, to where there are some cases you do not want the radio to do the spanning tree portion of it. You don't want the radios to look at who's connected and figure out which way we want the radio to block and forward the paths. It usually only occurs when the radio runs into a configuration conflict with the switches. But what this will do is that you have the ability to actually turning spanning tree off. So the radios itself will not run spanning tree over. So what you're doing immediately is you're turning off the ability to let the radio do mesh networking, because if you configure it as a mesh and then turning spanning tree off, radio will constantly send RF packets around in a circle, and we will effectively shut down the RF communication. But in a lot of cases, if we don't have redundant links, say you have one master talking out to two remotes, and the remotes don't communicate to each other, and we're not creating a link there, what we can do is if we turn the spanning tree off, the radio will not link or view the spanning tree across those paths. So if we're running into a conflict with the connected switch, which in a lot of cases also runs spanning tree, we have that as a troubleshooting capability. It isn't necessary, that's why it's turned on by default, but we can have the ability to turn it off in the bridge variables. The next thing is we can also pick which kind of spanning tree mode. We, by default, run rapid spanning tree. Spanning tree protocol is the older spanning tree, and then there's multiple spanning tree protocols. Each one of them works a little bit different from the network side, and it's kind of outside of what we want to get into today. Needless to say, you can configure the radio to match up to whatever type of network protocol works best for you. The next thing we need to look at is when we're talking about root bridge and the bridge priority. What happens is that if you set the radio as a root bridge within the network, effectively from the RF side, you're setting it to have a bridge priority of 0, which means that it has the highest priority, so it will be the lowest MAC address in the network, so it will be the root bridge. We're actually inside of the radio forcing it to do so. Well, what happens is if you have if you want to configure multiple root bridges within the network, but you don't want them to automatically associate, because if you set them both as root bridge, they both go to 0, so they both have equal bridge priority, so they fall back to the default, which is the lowest MAC address. That's just the way that spanning tree works. So if you want to manually put in which one it is, strangely enough, you will set neither of them as the root bridge. So both of them will actually have root bridge off. The difference is you'll set the bridge priority on your primary to 1. You'll set the bridge priority on your secondary to 2. And if you wanted to set up a third or fourth or however many root bridges you wanted to set up, then you just keep adjusting that bridge priority. The reason for that is that what that'll do is that then it'll go through and say, okay, well, who has the priority and who will be the root bridge is the one with that lowest bridge priority. So that becomes the primary. The one with 2 becomes the secondary. Okay? Those are really the only conditions that you'd ever get into where you'd have to adjust anything as far as the spanning tree. But again, what I wanted to point out more than anything else is these radios can be fine-tuned and adjusted for just about any type of application. So if an application comes up, you don't really know what setting to set it for, best thing to do is give us a call. We'll be happy to walk through what is going to fit best for your application. Now, another thing that we want to take a look at is how do we save or restore the configuration files. We had mentioned it very shortly in previous training sessions, but what you can actually do is you can create a backup file for the radio. beautiful part is that you can save it in one of two different locations. You can either save it as a file on your computer, or you can actually save it to the memory module, which is think of it as kind of a SIM module for um, like your cell phone, is that you can actually move the memory module from one radio to the next, and that'll allow you to take that programming from that one radio and restore it into the other radio, so it can become either it takes the programming for it, or you can actually do what we call cloning. So when you load it up, it's going to think within the network that that radio becomes that replaced radio. Why this is even all important, and the reason that we bring it up, is that if you've got a very large complex network, what we saw on the last training slide, when we set the radio link between the radios, you're actually linking the radios at the MAC layer. In other words, when you've got one radio, it links to another, they're communicating based upon their MAC address. Well, if we change one radio within the network, then what happens is the new radio coming in is going to have a different MAC address. So you'd have to change all the radios that talk to that radio, or if you clone it, it makes it look like the original radio coming out to it. That's why we have the difference in between the two. So this kind of gives you an idea of what the saving and restoring the configuration would look like. I'm going to actually go ahead and bring it up here on the page so we can see. So what I'm going to do here is, let me go ahead and I'm just going to press the home button here. This will take us back to the primary page. And as you can see here, the two that I'm making reference to is the backup and the restore. So if we hit backup, what we have the ability to do is we can back it up in one of two locations. We can back it up to our local computer onto the local PC, or you back up the current configuration parameters into the internal memory card. Then from the restore side, what we can do is we can basically do the opposite portion of that. If we press File, it will back up based upon a saved configuration file. Or if you go to the internal memory card, it can be based upon what is saved on that memory card. So the process you'd go through is, if you needed to move one radio to the next, you'd move the card from one radio into the new radio, and then you'd go into the restore page, and then you'd restore it from the internal memory. And as soon as you select internal memory, it's going to ask you, do you want to save it? I'm going to press the button here real quick so you can see it. Do you want to do it as a standard backup, or do you want to clone it, which will include the MAC addresses? So it's going to walk you through how to actually do that based upon which type we're going to be going into. So for example, you can do everything from setting it to factory defaults, if you have a file saved. So what it would look like, let me show you the process real quick. If I go in here and back up to the local PC, it's now going to create what's called a tar file, which is essentially the compressed file for a Linux-based computer. If I go over here to click here, what it's actually going to do down here at the bottom of the screen is going to create and save this configuration tar file. It's going to save it in the default location. So what I can do then from a restore is I hit restore, I hit file, I'm going to choose the file, click restore, and it will automatically then change those file parameters. There are a couple other things that we're going to take a look at, which is updating the software. So if we needed to update the firmware version inside of the radio, we may update it based upon bug fixes, or a lot of times we do it based upon features that are available out there. Really, there are a couple ways that you can do it. We either put them on our FTP site by default, and they'll be listed by the product on our web page, or it is something that can actually be emailed over, or you pull it from a cloud drive, something like this. You select the file that you're going into, you select the file for update. And the beautiful part is that because we are running this, if the radio links have already been established, this firmware update can be done over the air. And as we see here in a couple future shows, this firmware update can actually be done with a larger software package that we can do all of these configuration parameters to, the ESTeem Network Suite. It'll allow us to actually do the firmware updates over the air. The pages for them are going to look very similar to what we have here. So in other words, you're going to be doing it based upon an image file. You select the image file, or you're going to upload it via the web browser, which is going to be the primary means of doing so. As soon as you select next, What it's going to do, you hit the button for choosing the file. You select the file that it's going to update. It'll go up, reset the radio. The reset on a radio takes about 5 minutes or so to complete the update for it. You'll see the lights come back. And again, the easiest way to see that that has been done is to actually go in there and view it again in the discovery. Let me go ahead and clear the list, and I'll hit the discover button down here on the lower left. One of the things that'll show you is the firmware version is actually going to be one of the fields that it shows here on the screen. So if we needed to update the firmware version, we can do it through the discovery, but this will show you, and really what the firmware version is, you'll see here, it's actually a date code. So it's 2019 is the way that it's read, 0910, and then the time that it was actually done. So you can always tell what firmware version the radio has, or if you've got a later one, based upon the actual date code that is available to it. That really much covers everything that we'd ever need to do as far as inside of the advanced utility. I did have one quick question here that came up. It says, can multiple route bridges be configured using the path length, or can it be done only by using the bridge priority? The route bridge side of it is all based upon bridge priority level. The bridge priority level actually sets the parameter before we even get in and set the path length within the radios. The path length really directs where it's going to be going to, or what priority level it goes to. The bridge priority specifically sets the route bridge in the network. So hopefully that answers that question. And if any other questions come up about advanced, this is something that we can kind of give really an overview to, but covering each and every possible parameter is going to be kind of tough. This is one of those things that wanted just to give you an introduction to where to find some of these parameters. But again, these are the things that are really only going to need to be set for very specific cases. So if you've got any questions, if anything comes up and you're not sure where to set it to, that's one of the main reasons that we have the support available. We have give us a call, send us an email to support@esteem.com. We'll be happy to walk you through that. So again, I want to thank you for your time. The next section that we're going to cover in section 8 is actually how to configure the RS-232 data port so that we can run some more legacy hardware, and we can actually run that simultaneously. So thank you very much.